This is problem number 13. We're told we have a 5-year loan and we're making monthly end of month payments. We're working with a 9% annual interest rate, but it's compounded monthly. So I've worked that value out here, as well as its associated present value factor. We have this payment structure where we start by making a $1,000 payment and then decreasing by 2% as we go on until we get to the end of the loan. And we're asked to find the value of the loan, or the remaining value of the loan, immediately after the 40th payment. So we're going to start from that last statement, the actual question, and work backwards. What do we want to find? The value of the loan remaining after the 40th payment. So all that's really asking us to do is to sum up the final 20 payments. So let's have a look at our timeline and be sure we understand our payment structure. At the end of the first month, we make a $1,000 payment. At the end of the second month, we make that same payment but decrease it by 2%. So just 1,000 times 0.98. At the end of the third month, we make another payment that's 2% less. So 1,000 times 0.98 squared. And maybe you notice the pattern of the exponent on the 0.98 is going to be 1 less. We have this n minus 1 looking thing here. The exponent is 1 less than the month that we're on. So that makes it pretty easy to do a break in the timeline and then continue on until we get to the payments that we actually care about. So we want the value of these last 20 payments. And well, I know we've got a geometrically decreasing annuity formula. I couldn't make it work. So I think 9 times out of 10, the best way to go about solving these problems is get a clear timeline, understand what you're looking for, and then just go back to first principles. We want the sum of the last 20 payments, and those are in a geometric series. So we're going to take the first payment, 1,000 times 0.98 to the 40th, and we're going to subtract off the first omitted payment. So we imagine some fictitious payment on month 61. What value would go right there? 1,000 times 0.98 to the 60th. Now, present value factor is important. What point in time do we want to discount back to? Do we want to discount all the way back to the beginning of the loan? Well, the problem asks for the value of the loan immediately after the 40th payment. So we just need to discount this first payment back 1 month, and the 60th payment would be discounted back 20 months, but we're using the first omitted payment, so that's going to be discounted back 21 months. So that gives us our numerator, and we do 1 minus the common ratio for our denominator, and what factor is multiplying every single one of these terms? Well, it's the 0.98 times v. And maybe it would help to write out several of these factors, 41, 42, 43, to really see that. But from here, it's just put the numbers into the calculator and you get about 6,889, which is close enough to 6,890. So the final answer is B. And at the risk of repeating myself, when you are taking exam FM or even when you're practicing, half the time or more should be spent setting up a very clean timeline that helps you understand exactly what the payment structure is, what you're adding up, what you're discounting, to what point in time are you discounting. And then once you're real clear about exactly what you need to add together, 9 times out of 10, you can just go back to first principles and use this first term minus first omitted term over 1 minus the common ratio to get your answer.